Thank you. I'm so happy to be here. And this talk really is an invitation to you that we're working on this project of building high performance UI. It's under the Xilem kind of umbrella for the project, but I'm going to talk about, I'm going to give an overview of the pieces of it, but the call to action here is come and get involved in the project. So first I want to talk a little bit about the goals of the project. So the real focus of this entire thing is high performance. And that's actually a little bit of an unusual goal. Like most of the time you're more focused on developer experience and so on and so forth, but we really feel like high performance is the niche. This is why you would use Rust to build UI. So that's driving a lot of the decisions that we're making. We're also focused on a very rich 2D graphics model. We want to have full access to vector graphics with all of the goodies like gradients and also really good font support. I'll talk about that a little bit more. Of course, that's what I do. But we don't want to just, have something that's high performance and rich, but very hard to program. We also want to make a really ergonomic, easy to use API on top of that. And we want this to work on desktop and mobile. The project is being funded by Google. It's a research project that's being funded by Google Fonts. And the focus of that is Android apps. So there's like, we want to do both. We want to demonstrate a really good experience on Android, but I think the community is interested in desktop and other targets as well. So this is a research project. The goals of this, we're not offering this as a product, something that's fully ready to use out of the box. Maybe it will evolve into that over time, but the goals for right now are to discover what is the best way to build UI in Rust, and to what extent are we able to realize these goals of being extremely high performance and fully featured as a user interface. And we want to work with the community. This is maybe a little bit of a newer focus of the project, that we've been maybe a little bit siloed, maybe doing some of our own things. But if you, as I go through the slides, you'll see that there are a number of decisions that we've made about how do we cooperate with the Rust ecosystem instead of just doing our own thing. So this is kind of a picture of what the problems that you need to solve in UI. And I want to point people to Nico. Nico Burns did a talk on Monday, and there's also a white paper that's coming out soon. And that's giving that work is giving a much more complete picture of what you're seeing on the screen here. But we're seeing the problem in layers. So there's a top layer, which is reactivity. And this could be provided, like each of these layers, each of these boxes could be provided by a number of different crates. So this reactivity could be provided by Dioxys or Leptos. And then I'll be talking a lot more about what we're doing with this. And then there's a middle layer, which is solving a lot of the guts of what's involved in UI, of having a full collection of widgets and having gestures and layout and your text editing. There's a lot of problems that need to be solved at that layer. And then there's also a really important layer at the bottom of infrastructure. How do you connect to the platform, and how do you do the basic functions of drawing, text rendering, getting to your GPU, and accessibility? I'll be talking a lot more about that. So this is kind of our instantiation of this layered architecture. And so at the top level, we have the Xilem reactive architecture. In the middle layer, we have Masonry, which is our widget set, which does not depend on Xilem. So you could imagine using Masonry with Dioxys or Leptos. And then we're using Taffy for layout. And at the bottom, we have a mixture of things that are Rust ecosystem, like Winit. We made a decision. We switched over in January from our own platform integration to using Winit. And then a lot of the other things are things that we're building that obviously we're building for use in Xilem, but we're also hoping can be used by other projects in the Rust ecosystem. And again, Xilem is generic. There's a Xilem core, which is generic over the element tree that it's driving. So we can drive Masonry widget set and also give a demo of using the Xilem core to drive DOM and create an experience that can run in the browser. So the Xilem architecture, the Xilem reactive architecture gives you very simple code. Like this is your classic counter example. And this is really all of the code that there is. This is the actual code that I'm going to run. So it's a pretty simple, code to get this functionality. And if I run this, pray to the demo gods, we have a usable example. Very simple. And I'll tempt the demo gods a little bit more and do a little bit of live coding. Let's add a checkbox to this. So add a checkbox and test my live typing skills. And we'll call it is0. And will be checked if count is actually equal to 0. And then on the action, we've got the app state, which in this case is just a count. And we've got a Boolean for whether it's checked. And we'll just set the count to 0 or 1 based on sort of the opposite of the checked state. And we'll coerce that to 32. And this should give an error because check, but I'll just add it. Easier to type than to use the editor action. And this is a Mac M1, so this is going to be a lot slower than what you saw yesterday morning, but it's pretty fast still. And now we've got a checkbox there, and we can use that. And you know, if you it's reactive, so like if you change the count here, reset it, it's changing the checkbox state because that's all kind of computed in the app logic that's here. All right. Back to the slides. So, there's a few things that are a little bit different than a lot of the reactive layers that you see are derived from the JavaScript world, which is typically very dynamically typed. And I think Xilem is a lot more inspired by Swift UI than it is by JavaScript frameworks. So everything that you're seeing, all of these views that are created are statically typed. And that also means that the process of reconciliation, of diffing, this is all working with statically typed data. So it's going to be a lot more efficient than doing something that's dynamically typed. You'll also notice looking at that code that there are no macros in there, that these are actually fairly simple Rust value data types. Like, you know, when there's a string, well, there's no label in here. I'm not going to add a label in live coded, but it's really just a string. And then that string is a view that creates the underlying label widget, but the programmer doesn't really have to worry about that. So as I mentioned, there's a generic Xilem core. In this case, we're generating a masonry view, which is our native widget type, but you could also generate other things like web, and I'll show an example of that. So Xilem is based, the core of Xilem, drawing is really essential to any GUI toolkit, and that's also where you tend to spend most of the CPU time. Most of the performance is just how fast can you get this thing drawn onto the screen. And so that's a lot of what I've been doing over the past few years, really, is building a fast 2D rendering engine that does as much of the work as possible on the GPU. You want to do as little as possible on the CPU. You want to offload all of that work to the GPU. So it is implementing the full standard 2D imaging model. So we have vector paths with fills and strokes, gradients, images, clips, blends, and text. Let's go to the demo. Let's see, don't need to have too many things running at the same time. So I'm just going to run through kind of our standard test scene. So you always have the tiger, obviously. You need to have that. Some of these things, like we have a lot of things in there for stroking, because just in the past few months, we've moved from the stroke expansion being computed on the CPU to entirely being computed on the GPU. And actually, there's a paper that I just submitted to a conference. You can see the preprint. There's a lot of math that goes into computing this stuff on the GPU. Also, I mentioned the turn vsync off. Things go a lot faster. Here's a fun test scene that has, this is actually not a lot of strokes. We have test scenes in here. It has, tens of thousands of strokes. And so this one is showing a bunch of things. It's showing the animation and an image in there. And one of the things that we're also showing here is that our text and font handling is able to do variable fonts. And one of the goals, one of the things that's kind of driving this is to be able to do richer things like animate those variable font parameters. So you can go from light to bold, and you can animate the widths completely dynamically. And that's to get really high performance. This would be a major challenge with existing 2D graphics libraries. So this is just kind of going through. This is our engineering test scene. So here you can see all the different blend modes. There's more coming up that are sort of stress tests for how many line segments that you can have and still get decent performance. Yeah, this is another one. This is the motion mark example. And let's see, yeah, with the stats that you can ramp up to, I think it goes up to like 70,000 and still running at over 120 frames a second. So the performance, moving all of this from the CPU to the GPU just unlocks hugely increased performance. I'll show you another example that really shows off their performance. This is one of our standard test scenes. It's a map of Paris. It has 1 million path segments in the image. There's you can zoom in. You can see there's a lot of detail there. And when we're VSync off, you get hundreds of frames per second. And again, with standard rendering thing, it's challenging even to get 60 frames a second out of this particular test scene. So that's really a lot of what the Xilem project is about, is how do you exploit, if you have all that power, if you have all that graphical power, how do you exploit that from Rust UI? So there's a lot more to be said, including the multi-threaded encoding. Like if you're rendering a scene of that richness and complexity, and you're only able to get that data to the GPU from a single thread, that can easily be the bottleneck. So one of the goals of this project is have the different parts of the UI running in different threads and have it assemble all of these scene fragments together. So there's a lot of technical detail. I actually have a talk that I was going to put a link. I forgot to do that. I did a talk at Rust Lab last November, and I go into a lot more detail about the Vello engine. So if you're interested, go check out that talk. So the way that we use Vello in Xilem is also interesting, because this is a different API. This is not having a canvas context that has an and mute reference to it, which would restrict you to a single thread. So we have a model in which the widget in Xilem retains a scene fragment. So the scene fragment is kind of, you can think of a scene fragment as like a snippet of binary SVG. So if you're painting, you don't have to repaint the whole widget every time, that you can retain that scene fragment and only re-encode the subtree when it's changed. And so you can do things like change the transform. So if you're doing scrolling, you don't have to be re-encoding all of the content of what's inside that clip window. You can just reuse that and then have the GPU do all the work of re-rendering it. So it's all about making the CPU do as little as possible and making the GPU do the work, where it can be actually about 10 times as efficient in terms of how much throughput you can get per second or how much throughput you can get per watt. Another one of the layers, or another one of the bricks in that image, text is obviously really central to any GUI. And so we have this new crate, and all these crates, by the way, that you saw, the pictures that you see here in bold, most of these just got released in the last like 2 or 3 weeks. Some of them, I think the Xilem crate actually got released at midnight, so yesterday or today. A lot in preparation for this talk. Of course, we've been working on it for a very long time, but Parley is another one that got released, I think, maybe 2 or 3 weeks ago. And it's an advanced text layout engine. And so it does the basics of text layout. So it does paragraph layout with line breaking. It has the ability to set attributes. You can do bold and italic and all that fun stuff. But it goes, and of course, it's designed for performance, really metal performance. But we're also trying to do some richer things. So it supports variable fonts. And one of our goals, we don't have it, what you saw in the demo was not using Parley, I don't think. But we want to support variable fonts. We want to support the animation of variable font access and do like richer interactions in the UI. Parley itself, of course, it works well with Vello, but it is not tied to a specific 2D rendering image. So this is one of these blocks that you can mix and match however you like. There's some details here. It's depending. There's 2 crates that are kind of below Parley. One is called Fontique, and Fontique accesses the system fonts and enumerates them and figures out which font is needed to render which script. And there's also a crate called Scrifa, which does the low-level font loading. So this is really the Rust alternative to FreeType. I think one of the most exciting things about Scrifa is that there's work in progress to get this integrated into Chrome. And so that's actually in a Chrome Canary build, I believe, under a flag. But the goal is to make that really production quality to support all of the font loading that kind of low-level font needs that Chrome has, which is a pretty big requirement. Another major goal of our project is to support accessibility well out of the box. And so we're funding work on AccessKit, which is, I think, the Rust ecosystem crate for doing accessibility. And so it's a portable abstraction layer. Each platform has its own API for how it exposes accessibility. And so the Mac and Windows and Linux, more recently, backends are working pretty well. Android is in progress. That's one of our goals, to get that working. AccessKit is, of course, written in Rust, but there are bindings. We want to make that available for other languages. And there's some technical details I'll skip past and just go straight to the demo. So we'll actually use that same simple example. And I'll go into the settings here. And I think I'll probably turn down the offer to update my software and go into accessibility and just turn on voiceover. Great. Fantastic. So now I can use, why is it not reading out loud? The demo gods are not smiling on me. Voiceover on. You can see what it's supposed to be reading, and then it's not reading it aloud. This is, you'll have to see me after. This is really disappointing because I wanted it to be reading aloud. But I will at least be able to show that I'm able to use the keyboard to navigate the different widgets here and be able to control these widgets from the accessibility layer in the platform. All right, go see me after, and I'll get this demo working, and you'll be able to see it then. And then I should probably turn it off. Okay. All right. And then actually, while we're on the text layout, I want to show one of the other demos that I've got going here, which is our to-do MVC. And so this is all work that's in progress. This is not, there's a lot of stuff that is working, but there's a lot of stuff that isn't wired up yet. So we'll greet the Rust NL audience, and then let's translate it into, let's see, we'll go with Japanese today. Right. And so the input method works. So we're able to type in Japanese and have that work with the application. And of course, we're rendering that in the Japanese font and displaying it. And of course, it supports, pretty much all of the international scripts there. All right. Great. So the next demo that I want to show, there's a lot of demos here, is Xilem vector graphics. So obviously vector graphics is a major focus of what we're trying to do. And this is a different instantiation of the Xilem generic reactive layer. So instead of generating the native widgets like you've just been seeing, we can also generate DOM nodes, and in this particular case, really focused on SVG. So this is another instantiation of the Xilem core layer. And then we have a goal. There's an early prototype of using those same views and drawing them with the Vello drawing layer, but I'm not going to be demoing that today. Instead, I will be showing you. So we use this thing called trunk, which is just something that compiles Rust into WASM. And let's see, and then I'll pull up the browser, and we'll just go there. And we have now, so this is something that I was developing as a sort of interactive exploration of the curve stuff for the stroke expansion. And so you can move the curves around and you can change the offset. So these are all HTML and SVG elements that are under the surface here. And one of the things I wanted to show you is just how nice and beautifully interactive this is for exploration. So I can go into my editor here, and let's take that red stroke and change it to green. And then as soon as I do Command S, like watch what happens. As soon as I do Command S, it's about 250 milliseconds, and it rebuilds that WASM blob and loads it in the browser. And now I have a green stroke instead of a red. And that's fully recompiling this little Rust application. So that's, I think, showing some of the power of Xilem as a reactive layer. And we're going to be working towards convergence, so you don't have to write your code completely separately, once for the web and once for native. All right. So I also want to talk a little bit about some of the future work, and I think one of the reasons why I'm talking about this right now is that it motivates some of the design decisions that we want to do. So if you're using a UI toolkit at scale, you have to deal with large data sets. And one of the things that you absolutely cannot do is generate a vector, a vec, or an array or whatever of all of the elements in your scroll view and diff over that whole thing. That works up to a certain size, maybe up to 1,000 elements or so. But when you're dealing with really large data sets, you have to do this in a more efficient way. And so we have a plan. We have a rough prototype of this that hasn't been released, but like enough that I think we have confidence in this approach. And so what we want to do is to have a viewport. You know what's scrolled on the screen at any given time. You're only materializing the widgets that are in that viewport. And then there has to be a communications protocol between the widget layer and the view layer. So the widget layer knows what widgets are available, which ones are being scrolled into the viewport, and then you're sending messages. And these are actually, if you think about it, those messages are not that different than saying, hey, this button has been clicked at this time. But instead of that, you're saying, please materialize this widget that's being scrolled into view and dematerialize it when you don't need it. And it's actually a little bit more sophisticated, the logic that you need. Like, for example, if you have a widget that's focused, if it's a text view that's focused, if you scroll it out of the screen, you still want to keep it materialized because you don't want it to lose state. And the idea is that the widget layer has all of that context. The widget layer knows which widgets need to be materialized, which widgets need to stay there. And so it's in control of that, and it's asking the view layer, cooperate with me so that as new widgets need to scroll into place, get those materialized. So this is a fairly easy problem if you know the height of all of the elements in that list, because then the calculation for like where the scroll bars go and so on and so forth is just divide by the width. It's trivial. But we also plan to handle the case where the different children may be different heights. They may be posts in a social media app or something like that. And we're planning to do a fairly sophisticated thing where we use statistics to estimate those heights and incrementally refine them so that, as you scroll through, you're materializing more widgets, you have more accurate information. And so that's kind of a juicy problem. It involves computer science and a little bit of magic. Like, how do you hide, if you don't have that geometry exact, how do you hide that from the user so they don't really see the approximation going on under the hood? And then we also want to make the view layer ergonomic. So we want to have a rope-based vector so that it looks just like a vector. You can insert and delete and do all those kind of things. But if you say, here's the old vector and here's the new vector, give me the diff between these, instead of running down all of the elements in the vector, by using a rope, we'll be able to use sparse diffing, so it'll only look at the pointers that have changed in that representation and hopefully be super efficient. I think one of the motivations for this kind of approach is that you can't really do this completely seamlessly using web technology. It's very seductive to try and build on the web, and the Diaxis project is doing amazing things, building on the web, building on top of web technology. But there's certain experiences that you just can't quite reach. And we think this is one of those. And so we're really excited to build, a list view that has significantly higher performance. Another kind of characteristic of our project is we're really focused on working with the community, collaborating with a lot of other great projects that are out there. So as I mentioned, we have switched to using Winit for our platform integration. Previously, we had our own crate because we thought, maybe we can do these things a little bit better, but we've really decided we're going to be working with Winit, and we're going to be trying to do our improvements into Winit so that it can benefit the entire Rust GUI ecosystem and not just our project. We also made a decision about 1.5 years ago to switch all of our GPU infrastructure, instead of doing that ourselves, to use wgpu. And I think that decision is really paying off in a big way, because we are able to interop with other applications, and there's really amazing work. You've all seen the Bevy stuff. There's a lot of applications that people are building on top of wgpu. There's AI and machine learning stuff that's using the compute capabilities of wgpu. And this is a real goal of our project, that if you have an app that's doing rich 3D content, we want to be able to mix and match that with the Xilem content in a completely seamless way. And of course, if we had built our own GPU infrastructure, maybe we would be able to optimize, incremental present on Vulkan a little bit better, but we would be giving up that ability to interoperate with wgpu. We're also working with Nico Burns on Taffy. So we're bringing in Taffy to do the layout. There's a demo. I'm not going to show it. I think I've probably tempted the demo gods enough, but there is a Taffy demo, and you can play with that. And then we're also, a lot of the crates so these are crates that are, the ecosystem that we're using, but we're also building a lot of stuff that we think is going to be potentially really useful to other people that are building these 2D apps that are out there. So I think the big one is Vello. The world needs a very high performance GPU 2D rendering engine. And I think Vello is becoming that, and we're starting to see that being adopted by other projects. So the Blitz renderer, which is also known as Stylo Dioxys, it's the native rendering layer in Dioxys. That's using Blitz. We're looking forward to them. We're having conversations over lunch. We were talking to people at Servo about maybe using Vello to do some of the content in Servo. And so we really want to make this something that can be used by everybody in the Rust ecosystem, and not just if you're using Xilem as the toolkit. Text layout is in the same category. And I should add, we're aware of the work that's being done in Cosmic Text. That's really good stuff. And, we looked at that and decided to go our own direction because we feel that there are certain things that we can do better. And text is also, I'm working on the Google Fonts team. I'm working very closely with engineers on Chrome and other projects inside Google. So, we felt we can do a better job on text. At the same time, a lot of the stuff that we're doing, if you're using Vello, if you want to use Vello with Cosmic Text, we have a demo of that application. That works. We want to support that as well. But we're hoping that this Parley text layout library is something that can be used again across the ecosystem. And then, of course, AccessKit. Everybody needs to do accessibility in their UI toolkit. And I think we've been seeing, when new UI toolkits pop up, it's very common for them, even out of the box, to be including AccessKit. And that's really, really great to see. So today, what you're seeing is a snapshot. You're seeing work in progress. A lot of this stuff is, still in rough state and being built. So over the next few months, we definitely want to build out more of the widget set, all of the stuff that you expect in a UI toolkit. A lot of that we're going to be importing from Druid. This has sort of roots in the Druid project. And so there's a lot of code there that we think we can adapt pretty quickly. We also want to build that high-performance scrolling list view. That'll allow us to test out a lot of our performance ideas. Are we really able to realize that kind of dramatically stepped up performance over the current state of the art? And then, of course, we want to make this work really well on mobile, really work well on Android. And so the IME, the soft keyboard, is a major challenge. There are not a lot of things out there that do this well today. That's one of the reasons why you saw the IME demo earlier, is we need to get the interface with the IME smooth so that we can get that working really, really nicely on especially mobile platforms. And there's a lot more to be done on development tools. There's actually Olivier, who's one of the people working on the project, showed me a demo of a widget inspector that he's working on. That's part of if you read his blog from earlier this year on the plans for masonry, you'll see that the widget inspector and testing and developer tools are a large part of that story. So that's so this is all stuff that we're working on. And we have a very I think we've been putting time and effort into making ourselves into a good community. I feel Rust needs, we used to sort of have r/Rust as the gathering place where everybody came together. And I think that we're moving into a world where we're growing past that, where there's sub-communities. And we want to be the sub-community, not just for the Xilem project, but for 2D graphics and Rust GUI. And so we have the center of our community is a Zulip instance. And of course, anybody here is welcome to go and sign up or just browse. You can browse it. You don't need an account to read it. So that's the sort of central gathering place for a community. We have a blog we're updating. We have a monthly update we send out every month. And then we have special topics on what we're doing. And then another feature is weekly office hours. So anybody who's in Delft tomorrow at 5 p.m. Dutch time, please come by, and you can see me about the technical details. But we hold office hours every week. We don't post those to social media and stuff like that because we don't want to be swamped. But if you're interested in building or actively using Rust GUI, you are welcome to come by those office hours, and those are a really great, productive way to engage the community. So that's a goal. We don't want to be a closed, a walled garden. We want to be open. We know there's a lot of really excellent work. You've seen, yesterday and this morning, some of the other Rust GUI projects that are being done, and we want everybody to be working together and collaborating towards a future in which we have the advantages of Rust, but we're also building really great UI. So that's my talk.
Thank you, Ralph. Are there questions? Yeah. And please.
Hello, thank you for the great talk. It was very interesting. So I maintain a crate called Ratatouille. It's a terminal user interface library for Rust. And my question or the idea is, can we use, so you mentioned Xilem core can be used to, in a generic way to render in the web. Can we do the same for the terminal by using Ratatouille as a widget provider?
I think so. I know, I can't remember off the top of my head. I think there's been a little bit of exploration of using Xilem core for TUI. I don't think that's a completely new idea, but absolutely. Let's explore. Let's find out what works well. Maybe what are some of the pain points. Try it.
Hi, thank you for your talk. Quick question. If I am not mistaken, Skia was working on a backend called Graffiti. Graffiti was trying to do something like this. Is there any shared experience since between this project and what Skia is doing?
Yes. So I do work pretty closely with people on Skia. So Graphite is the next generation after Ganesh of Skia's GPU-based rendering. But Graphite's a bigger project. The current state of Graphite, they're not using compute shaders to do the rendering. So it's a step, but it's not a big step in the way that Vello is. So we do have a prototype integration. It's all in very early stages. None of this is anywhere near ready for production right now, but we have a prototype of using the Vello path renderer as one of the backends inside Graphite. So as this develops, I'm hoping that more of this stuff actually lands in Skia, but at the moment, and that would be through Graphite, but at the moment, this is all kind of early explorations.
Thank you for the talk. So I've been following you and your talks for quite a while now, and the key takeaway of most of the talks is this is all nice stuff, and we are researching a lot of things. And yeah, if you're interested, have a look, check it out, but maybe not use it for anything serious. So my question would be: you presented a lot of projects. Has that changed? Are there some that you would say, this is something that you could actually use, or maybe still wait a little bit longer? For instance, Xilem might be very interested in looking deeper into that, but it's always like, maybe not.
It's a good question. Thanks for raising the question. So first of all, there are pieces like, for example, Skrifa, the low-level font loading, is absolutely ready to use in production today. So I think, maybe thinking about it as, and I think AccessKit, it's still in progress, but I think taking a dependency on AccessKit today is a really good idea that I would recommend. I wish I could say the same. Like, I think Vello is becoming that. It's not quite there yet, but it's well on the way. I think people are starting to integrate Vello. And then as for the higher levels, yes, this is explicitly a research project, and that's a double-edged sword. That there's a lot to be said for saying, let's just take our knowledge of best practices of how to build stuff and just do the engineering and build a product. And that isn't what I've personally been doing, much. That there's so much interesting research to be done, and I see like there's so much better ways of doing things, and I want to explore that, and that's intention. With I just want to build a GUI today, and I'm very sympathetic to that. So I think the answer is I want us to be moving towards that. I wish we were farther along on that journey, but I think we are on that journey, and so the invitation is the same. It's like, join us on that journey. Let's see what we can learn, and also, have our projects cooperating a lot more with other projects that are maybe a little bit more focused on shipping a usable product in a short period of time.
So what are the odds of Xilem becoming the next Druid?
I like to think that Druid had mistakes in it. And I like to think that Xilem fixes those mistakes and is a more sustainable project. And I think the way that the community has been coming together and building it is a really positive sign that it has legs.
Okay, so Xilem is there to stay.
I hope so.
What you sincerely hope?
I hope so, and I think so.
Thanks.
I would like to thank you for investing in accessibility, first of all, because I think it's very, very necessary. Little people do that, little organizations do that. But your demo also shows that there's a bit lacking in the screen reader department. Is your organization, is Google, interested in investing in screen reader department?
I can't speak for what Google is going to invest in. I mean, certainly we are. I mean, the specific thing of it not reading aloud is just demo effect, and I don't know what went wrong there. Like, that does integrate. It absolutely does work, and it's just not when I'm on stage, I guess. So, I mean, Google obviously does a lot of investment across the board in accessibility technology, in Android, in other products that Google ships. So that is certainly going to continue. And then, we're very happy to support AccessKit. So, like, anything that's rough and not working quite well today, we're absolutely going to be fixing that. And we're very happy to be working with Matt Campbell, who's the real creator of AccessKit.
Someone online is asking how the story with Xilem would work in combination with async. So how would you, for example, make an HTTP request?
Yeah. We just ripped the async out, which is fun. But we had a prototype where we had async integrated fairly deeply. So you have the ability to do waking, which is, of course, the primary point at which async integrates with a UI toolkit, on a per widget basis. So again, this is a prototype that we had working, and then when we were making various different transitions to win it, that was part of the thing that we ended up taking that out. But we are planning on bringing that back. So you absolutely would be able to have a widget that says, send off a network request, and then paint the widget based on the the loading state while you're waiting for the request to come back. And so there's a prototype. I can point people to the code, based on kind of an older version. This is why it's research. It's like we need to figure out the best way for all of these pieces to come together. But it's planned.
I think this is the final question.
Hello, I've also been following your work for some time, and I remember in Druid there was this a bit bizarre layer of integration with the system, like file dialogues and application persistence with window closing. What did you do with that in the new Xilem architecture?
Well, I mean, the platform integration, we've just switched over to Winit, and that does mean that we've regressed. So there is not a file open dialog in Xilem at the moment. And so we do plan on porting that stuff on top of Winit. I think there's some really good questions of, do we do that in a way that's specific to Xilem, or do we try and make a more general crate that could be used by other things in the Rust UI ecosystem? I think that's a little bit open. Like the current state is, we're trying to get the new infrastructure really functioning and then pull in pieces from the kind of previous Druid.
Yeah, one such crate was mentioned earlier today. I don't remember the name, but yeah.
Okay, so give a huge hand to Ralph for his stuff. Thank you.